forward so that we allow those who are coming in to sit at the back. So kindly.
Tumeuona mkono wake Bwana,
mengi mazuri tumeyaona, Mungu umetenda, ni kweli wewe muweza. Ulitamka vitu vikawa, neno tulatosha, ukisema umetenda. Kawatoa utumwani, watumishi wako umewapa yote waombayo, ikiwa umependezwa.
uamualo hakuna wakulipinga, hakika wewe ni Mungu
wa vyote.
Unatawala dunia na vilivyomo, makuu umeyatenda Jehova. Hakika tumeona
Baba, mkono wako Bwana, kweli matendo yako Bwana ni makuu, na umetutoa mbali kweli, ukatushika mkono Mungu mahali ulio na wewe. Chini hata chini yao watu unawainua, Mungu sifa na utukufu ni Msalabani ulitufia, ulitupenda, dhambi zetu kabeba. Baraka zako tuliziomba, kweli tumeona, hakika unabariki. Hata vipaji wendo hutoa, umetuwezesha, tunaimba na kusifu. Walio haki hutoacha, uliwaahidi, hata mwisho wa dahari.
Watu wako umewapa mamlaka, kwa jina lako Yesu waponye. Hakuna ubaguzi, wote ni sawa kwako, umetuita Yesu tupone. Hakika wewe ni mwema,
tumeuona Baba, mkono wako Bwana, kweli matendo yako Bwana ni makuu, na umetutoa mbali, kweli ukatushika mkono Mungu, mahali uliona pekee. Chini hata chini yao watu unawainua Mungu, sifa na utukufu ni zako milele. Na tutakusifu jina lako Baba, milele tutakusifu, kweli daima wewe mwema, tutaishi kwako. Tumeuona Baba, mkono wako Bwana, kweli matendo yako Bwana ni makuu, na umetutoa mbali, kweli ukatushika mkono Mungu, mahali uliona pekee. Chini hata chini yao watu unawainua Mungu, sifa na utukufu ni zako milele. Na tutakusifu jina lako Baba, milele tutakusifu, kweli daima wewe mwema, tutaishi kwako.
Tumeuona mkono wake Bwana,
mengi mazuri tumeyaona, Mungu umetenda, ni kweli wewe muweza. Ulitamka vitu vikawa, neno tulatosha, ukisema umetenda. Kawatoa utumwani, watumishi wako umewapa yote waombayo, ikiwa umependezwa.
uamualo hakuna wa kulipinga, hakika wewe ni Mungu
wa vyote.
Unatawala dunia na vilivyomo, makuu umeyatenda Jehova. Hakika
tumeuona Baba, mkono wako Bwana, kweli matendo yako Bwana ni makuu, na umetutoa mbali, kweli ukatushika mkono Mungu, mahali uliona pekee. Chini hata chini yao watu unawainua Mungu, sifa na utukufu ni zako milele. Na tutakusifu
from across the globe. For now, I request that we be upstanding for the national anthem and the East African anthem. Mungu nguvu yetu.
Afrika Mashariki, tuwezeshe kuishi kwa amani, tutimize na malengo yetu. Jumuiya yetu sote tuilinde, tuajibike, tuimarike. Umoja wetu ni nguzo yetu, idumu jumuiya yetu.
Thank you so much. Let's get seated for the next session. My name is Jane Macharia, and I was the communication chair for the conference secretariat. I take this opportunity to welcome the MC for the session, Ms. Linda Boyer. Welcome.
Good afternoon. This afternoon, we are privileged to have the official opening ceremony of the second joint international conference with the theme Harnessing Biodiversity and Cultural Heritage for Economic Transformation. Our theme is very important because many a times culture and nature and heritage are not considered economic value, but we can see globally that this is changing. So to start us off, we'd like to invite Professor Esther Kioko, who is the chair of the conference, to give her opening remarks.
Good afternoon. This afternoon, I stand here to just give a few remarks, and I would like to say that it is with great honor and deep appreciation that I welcome all of you, our distinguished delegates, scientists, researchers, students, research partners, and our financial partners, and all our guests to this second joint international scientific conference. And on behalf of the Secretariat, I extend sincere gratitude to all the institutions whose dedication, coordination, and collaboration have made this important gathering possible. The Secretariat, which I chaired, has played a very central role, and I would like to appreciate all of them as they were planning, coordinating, and executing these matters pertaining to this conference. And they ensured that all the logistical, scientific, and administrative processes ran smoothly and efficiently. And this included coordinating abstract submission, supporting the peer review of the abstracts, facilitating the communication between the organizing institutions, and ensuring that all the participants have a conducive and environment for this scientific engagement. The great success that we are seeing during this conference is therefore a reflection of teamwork, institutional collaboration, and shared commitment to advancing scientific knowledge. This conference that we are experiencing now is hosted with a strong framework of collaboration between key scientific institutions that include the National Museums of Kenya, and I really appreciate the chair of the National Museums of Kenya board, Mr. Edwin, and our Director General, Professor Mary Kikungu, because of the support that the Secretariat has received during this planning for this conference. Also, we had our Kenyan Association of Entomologists, which is chaired by our sister here, Dr. Samita Namikoye. The association gave great support as part of the organizers of this conference. Of course, we have the third participant in hosting this conference, the Sino-Africa Joint Research Center. We call them in short SAJOREC. I'm sure you've seen their tent outside. And they are represented here by their Director General, Professor Wang, all the way from Wuhan Botanic Garden. Professor Wang, we appreciate your presence and also your participation in the hosting of this conference. He's not alone. He came with a big team. I'm sure you have seen them amongst us. So thank you, our colleagues from China, for joining us. In addition, this conference organizers received great support from our other partners, especially those who gave in some financial support, starting with the JRS Biodiversity Foundation all the way in the US. We received financial support and also exhibition from the ICA Lion Group. I think they gave a few remarks just before lunch. We also had great support from our Kenya Museum Society, who support a lot our work here at the National Museums of Kenya. We have a team from Fauna and Flora International. They gave the first symposium this morning. They also played a key role in supporting this organization. The Liaison Group, they are also here, also exhibiting. The Impala Research Center in Laikipia, they supported especially the pre-conference training as well as also the conference. We have the British Institute in Eastern Africa. They've been a key supporter to this event, and the African Academy of Sciences. We appreciate your financial support to this event. And this support from the research partners, the supporting agencies, it shows or it demonstrates partnership and the power of interdisciplinary and international cooperation in addressing global challenges in biodiversity conservation, climate change, matters of environmental sustainability, agriculture, and public health, as spelled out in our sub-themes for this conference. We all know that today the issues of biodiversity loss, habitat degradation, invasive species, climate variability, emerging diseases, they require not only strong scientific inquiry, but also coordinated action across disciplines, institutions, and even borders. And in this regard, as the secretariat of this conference, we greatly appreciate the great diversity of abstracts that were submitted for this conference. We were so overwhelmed to receive participants from across the entire African continent, with the 13 countries in Africa represented, and also globally. We have 8 countries outside the African continent represented here, and to us that was a great, and is still a great joy. Across Africa, we have Kenya, Uganda, Tanzania, Rwanda, Namibia, Ghana, Zambia, Nigeria, Ethiopia, Malawi, Cameroon, Congo, South Africa. So you can see the great diversity from the north to the west to the east. We are very grateful, our brothers and sisters. And of course, from outside the continent, we have representation from our co-hosts, China. We have representation from India. And without Kipendeleo, Kiafrika, let me mention one of the representatives from India, Professor Suresh Raina. You know, it's good, we say, tupatiane maua. He was my PhD supervisor. And when he heard that we were organizing this conference, he knows our Director General, Professor Mary Kikungu. He said, Esther, count me in. And he paid for himself to come here and give a keynote address. Professor Raina, we appreciate you. Thank you for coming. We also have our sisters and brothers from Russia. We have people, representations from the United States of America. We have colleagues from the United Kingdom, Switzerland, South Korea, and Australia. So thank you so much for burning a lot of miles to come and be with us. We appreciate your presence. So this conference provides a very vital platform for researchers to share findings, exchange ideas, and develop innovative solutions that are both scientifically sound and practically applicable. I would also like to acknowledge the dedication of the scientific committees, the abstract reviewers, the technical teams, and volunteers whose tireless efforts behind the scenes have ensured the successful organization of this event. It's not just the Secretariat. We have a lot of people just behind the scenes whom you have not seen, but they've done a lot of work. We appreciate them. And with that, I would like now to just wish you on behalf of the Secretariat a great, great time in the conference and also in our country, Kenya. Thank you.
Thank you, Professor Kioko. Our next speaker or guest is Dr. Namikoe Samita from the Kenyatta University, who is also the chair of the Association of Kenya Entomologists. Welcome.
Good afternoon. The guest of honor, Professor Wang, the chair NMK board, Mr. Edward, the DG NMK, Professor Mary, and all the participants. Good evening, good afternoon. Yeah, it gives me great pleasure to welcome you all to this second joint conference. As we gather here today, being an entomologist, I'm reminded of the tiny leaf ants that can build massive anthills together. Alone, we can do so little, but together we can do so much. These words capture the spirit of this conference and the vision of AKE as a professional community united by the common passion of insect science, innovation, and service to society. It reflects upon all of us. Allow me to give you just a brief about the Association of Kenyan Entomologists. It was registered in 2024, but it succeeds the former Entomological Society of Kenya, which was established in 1993. This AKE is a non-profit professional organization, and it's dedicated in advancing entomological science and its application in Kenya and beyond. Our membership for now is at 215 members, cut across Kenya, Africa, and even beyond. It also draws from a diverse group of institutions, among them universities, research institutions, international organizations, technical colleges, and even the private sector. More of them are holders of PhDs, but our joy is the young ones that we are bringing up, whom we are mentoring, students, and some of them are highly participating in this conference. We are very proud to be associated with NMK because most of our members also come from here, and I'm happy today to note that the DJ of NMK is our very, very good member, Professor Kioko, and many others from NMK, and we know that from today, we are also likely to get membership from Sajorek and all the other partners that are here. AKE also aligns itself with the regional and the global professional bodies. Among them, we have the Association of African Insect Scientists, which continues to champion the insect science across Africa. This reminds me that even as participants were giving their talk here, one of the key questions was, where are the insects in this? We will see the mammals, we will see the fish, and this is why AKE is here, because we would want to say that even as you talk about the bigger things, the animals, the mammals, the land, the earth science, don't leave out the insects, because the insects would also give a lot of information. So today's conference reflects on the growing importance of entomology in addressing continental and global challenges across Africa. Insect scientists continue to play a very key role in responding to migratory pests, invasive species, which some of you have given very good talks, vector-borne diseases, and this is both in plants and animals, biodiversity conservation, food security, and environmental sustainability. So in Kenya, our members have actively contributed to national responses against the fall armyworm. I'm sure in your various rooms, probably you have come across the fall armyworm. We have currently the Pasea mites in avocado and the mealybugs in various crops, which have given farmers sleepless nights, the fruit fly infestation, and many other threats that are threatening farmers. So as scientists, we recognize that the knowledge must not just remain in your labs or remain in your species, your species, or the journals alone. So this science communication through this conference is very key, because it's ensuring that research contributes meaningfully to society. So this conference therefore provides very important platform for sharing these ideas, for strengthening our networks, for mentoring the youngsters, which I'm very passionate about. I'm a senior lecturer at Kenyatta University, and that's a passion I do really have. And apart from that, also building solutions for today and also for the future. I wish to sincerely acknowledge the very strong partnership that we have with NMK, with Sajorek, and all the other partners who are here. And I'm sure I've been to your exhibitions, and I've talked, and I know that we are going to go far. So AKE, in organizing this important international conference, we also want to extend the very heartfelt appreciation to our sponsors, partners, organizing committees, presenters, and participants whose dedication and support have made this event possible. As we continue to spread our wings as AKE and as our other partners, let's move forward with the courage and strength of the dung beetle and the unity and vision of the honeybee. Let us continue to dream boldly, work collaboratively, and inspire the next generation of entomologists and many others who are also aligned with the entomologists across Kenya. May this conference inspire new ideas, stronger collaboration, and lasting impact in advancement of everything that we are doing together. Thank you, and I wish you a very fruitful deliberations throughout the conference.
Thank you, Dr. Samita. Our next speaker this afternoon is Professor Mary Gikungu, who is the Director General of the National Museums of Kenya. This conference has been fully supported by her efforts, and that's why we are all here today. Welcome, Professor.
Our distinguished guest of honor, Professor Wang, Director General, Huan Botanic Garden, our Chairman of the Board, Mr. Edwin Abonyo, the Chairperson of AKE, Dr. Samita, the Chairperson of the Secretariat for the conference, Professor Esther Kioko, our distinguished guests who are here, and all the participants. Good afternoon. I'm so delighted to see each one of you, and we take it such a privilege as National Museums of Kenya to host the second International Entomological Conference at NMK. May I take this opportunity to welcome you once again to the second Joint International Scientific Conference 2026. Once again, we proudly converge at this institution after successfully hosting the inaugural joint scientific conference that was conducted here in June 2024. As National Museums of Kenya, we continuously promote activities that align with our core mission, which is to collect, document, preserve, study, and present Kenya's natural and cultural heritage. For those of us who come from Kenya, we are known by one name, which does not represent us, Museum Kwanyoka. Now you know, we are more than snakes. For those who cannot understand that, they say that this is where snakes are found in Kenya. So they associate us with snakes. As National Museums of Kenya, we continuously promote activities that align with the core mandate of our institution. And while Kenya is endowed with rich natural and cultural diversity, the pressing challenges of climate change, habitat destruction, and biodiversity loss continue to threaten the very roots of our existence. This year's theme, Harnessing Biodiversity and Cultural Heritage for Economic Transformation, is a crayon call. We are enhancing our strategies in documentation to active utilization and management of biodiversity and natural resources for impact and sustainable utilization. By integrating the scientific research, indigenous knowledge, and technological innovations, we are developing holistic strategies that drive the government's economic transformation agenda. Ladies and gentlemen, in order to create a more interactive exchange platform among the participants, this conference, as you are aware, has been organized to include the very important keynote papers that have been presented to you so far from renowned scientists from some of the most prestigious institutions across the globe. Secondly, capacity building program aimed at nurturing the next generation of scientists. I envy you young people. For some of us, we missed this golden opportunity. But congratulations for the good training that you have been given so far. You will agree with me that the Pathways of Emerging Biodiversity, Change Makers in Africa program will create a huge impact on our upcoming scientists. And lastly, the specialized symposia will offer the participants an in-depth interaction on some of the topical thematic issues. I wish to express my sincere gratitude to our co-host, the Association of Kenyan Entomologists, Dr. Samita and the team. We appreciate you. And Sino Africa Joint Research Center, SAJOREC, for the completing our efforts in this initiative. Similarly, we also appreciate support from various organizations, including the GRS Foundation, among many other local and international organizations that have been mentioned by Professor Kioko. Our collaboration represents a powerful alliance between regional expertise and international research excellence. Allow me to add something of my own. In the next conference, I think I should be one of the presenters. Now that my mentor, Professor Raina, is here presenting, coming all the way from India, and Professor Ingore from Moi University. Yeah? At University of Eldoret. And Dr. Samita, still recognizing me as an active member. You can be sure I want to be one of the presenters in the next conference. As we embark on these remaining days of discovery, let us remain steadfast in our commitment to inclusivity and shared stewardship. Together, we have the power to safeguard our planet's natural and cultural wealth and secure a prosperous future. I thank all the partners and sponsors for their generous support in making this conference a reality. And before I end my remarks, allow me to thank the Secretariat for the good work that you have done. Every time they came to me, there was a feedback. Prof, we are doing well. We need this letter. They would do it in good time. Professor Kioko and the team, the management, the senior management members who are here, including Professor Mandi, seated there, and Dr. Terrell, who is the Director, Research and National Repository. We really appreciate the effort that you have made, all of you, to make this conference a success. Thank you, and I wish you all very fruitful deliberations during the conference. May God bless you. Allow me also to invite and also thank sincerely the chairman of the board, Mr. Edwin Abonyo. The members from NMK, you know very well, chairman is very, very, very supportive. And we are very happy that he is here with us to make his remarks. Thank you.
Thank you, Prof. I will not say good afternoon. Hamjambo. Haya, mjafundisha hawa lugha yetu bwana. Hamjambo tena. That means how are you in Kiswahili. So for those of you who are coming outside this country, away from Kenya and maybe from Africa, that is a formal greeting. But if we're in a church, tutasema God is good. And all the time? Yeah, I can see there are a number of Christians here too. Thank you. Now, you've been told, I'm Edwin Abonyo. I'm the chairman, National Museums of Kenya. And I'm happy to be here with you. And I feel humbled and honored to have been given this opportunity to address you. If you recollect last year, we had a similar, actually 2 years ago, which was done by our then head of public service, Felix Koske. He was the chief guest then. I hope I'm not wrong. Sometimes we mix up things. But Professor Wang, karibu sana. You're welcome. And I'm happy you're here with us. Dr. Samita, asante na karibu sana sana. Prof, now there are two professors there, and I'm sure there are several in here. If I say I'm going to mix you up, so I'll say Professor Mary. Karibu, and thank you very much. And of course, Kioko, asante. Of course, in your midst there are also a number of people that at least I recognize, and I was happy to see. When I walked in and I sat, the first person I saw was Professor Raina there, with the mustache. He's a guru from India. Thank you very much. You've done a lot to us. In any case, you are the supervisor of Kyoko, isn't it? So you have a product here running this conference. So let's put your hands together for you. Thank you. And then, of course, we have our own. We also have our own achievers here. And of course, they always relate to the conference. I mean, they all came from NMK. We have Professor Manthi here. Manthi, karibu, although you are part of this place. Manthi, for those of you who don't know, he was recognized in the America, it's called American what? Academy. Manthi, say it loud. We like blowing our horns, so don't just sit with your nini there. Pardon? Thank you. He was recognized, and that was very good. So Dr. Terer is also there, and several of our team members. I'm seeing Mwadime there. I'm seeing Terer. Fanya tu mkono namna hii. Yeah, thank you very much. So we have them. I'm sure they've been mixing with you throughout this conference, and unfortunately, I couldn't join you yesterday, and then unfortunately also our CS was not able to join you. As we are talking now, they are having a cabinet meeting, and our PS was also engaged in other matters. But nonetheless, they are with you and they are supporting this conference fully. So, on behalf of the Board of Directors of National Museums of Kenya, I wish to welcome you again to this second joint international scientific conference gathering that represents our commitment to the convergence of science heritage and national development. As NMK board that I chair, we have a responsibility to provide strategic oversight and policy framework that enables NMK to fulfill its mandate, which is to collect, to preserve, to present Kenya's rich natural and cultural heritage. We recognize that in this 21st century, a museum's role must evolve beyond being a storehouse of the past. It must become a catalyst of the future. This year's conference theme, Harnessing Biodiversity and Cultural Heritage for Economic Transformation, perfectly aligns with the government of Kenya's economic transformation agenda. So as an organization, we are particularly focusing on how our scientific assets can be converted into tangible economic opportunities. At this point, I'd also mention to you that we have quite a number of programs running, even as you are doing this. We also have one with NPI. It's a very, we have national products industry. We took it up and it's domiciled under where Dr. Therese is heading, and we are doing a lot. We are trying to harness and enhance, and I don't know which other English word I can use, to recognize our cultural heritage, our medicines, our foods, our dances, and so on and so forth. And we want to take it to another level where we could even use it to get money, for economic transformation of the country. So through nature-based enterprises that empower rural communities, climate-smart agriculture to ensure food security, or carbon and biodiversity markets, to being global investment into local conservation, among others. We are committed to ensuring that NMK remains a hub for mentorship and guidance to early career professionals by providing attachments, internships, affiliation, and mentorship opportunity in collaboration with other partners. Through the mentioned programs, we commit to a continuous investment in intellectual capital that will lead to conservation of Africa's natural and cultural assets for posterity. So to the young scientists, our young scientists, we encourage you to make great effort and utilize this opportunity to mingle and network with the diverse expertise in this forum. So ladies and gentlemen, the challenges of heritage loss, partly due to climate change, are significant, but so is our collective resolve. To address these challenges, the Board of Directors remains steadfast in supporting partnerships and interdisciplinary dialogues. So, quite a number of things I also got to learn when I just came in here. Like about, you were 300 of you here, delegates from 26 countries. That is quite a good attendance, and I think we should clap for ourselves. For Professor Wang, Sajorek has done quite a bit for us, and we cannot fail to recognize that, even if it's not in my main speech. I'll have to find a place to insert it. He's done for us over 50 students who are being trained. And he also told me that he's going on with it, and there'll be more to come. Thank you, Prof. Thank you, Prof. So, and of course, for this conference, he did pre-training for 150 students. So thank you also very, very much for that. Thank you. So, Samita, don't worry about the smallness of the small things you're studying. There's another smaller one that is causing havoc in this country. You know what it is. It is one of the biggest problems we have in this country. In fact, I think is it the fourth largest killer at the moment? Maybe you need to check. Don't go with my statistics. It might change. So I wish you well for this productive networking. What you did yesterday, what you're doing today, and what you're going to do tomorrow. I wish you well. And with that, I would like to welcome Professor Wang, our main guest today, to also give us his address. Thank you. Let's put our hands together for Professor Wang. Thank you. May God bless you. Thank you.
Thank you, Chair. Honorable Chairman of the National Museums, Mr. Edwin Jacob Aboliu, Director General of the National Museums, Professor Mary Kikungu, Professor Kioki, Dr. Samita, and all distinguished colleagues. Dear friends, ladies and gentlemen, good afternoon. So on behalf of the Salo Africa Joint Research Center and the Wuhan Botanical Garden Chinese Academy of Sciences, it's my great pleasure to welcome you to the second Joint International Scientific Conference. I would like to extend my sincere gratitude to the National Museums of Kenya for its thoughtful preparations and hard works in making this conference possible. Thank you. This conference brings together scholars, researchers, and policymakers from around the world to exchange insights on conservation, sustainability, and inclusive development. The vision of this conference is clear: to build a platform for dialogue, collaboration, and action, enabling biodiversity, research, and cultural heritage protection to contribute meaningfully to sustainable economic growth in Africa. So Africa is extraordinarily rich in biodiversity and natural heritage. At the same time, it faces increasingly urgent challenges arising from the climate change and growing economic pressures. Strengthening innovation in Africa is not only vital to the sustainable development to the region, but also a shared responsibility of the global scientific community. The Chinese Academy of Sciences has long attached a great importance to cooperation with Africa. The South Africa Joint Research Center has committed to promoting joint research, capacity building, and talent development between China and African countries. So I still remember we signed a MOU with the National Museums of Kenya and started the collaboration from 2014. That's more than 10 years ago. So through the joint efforts of our Chinese and African partners, a series of research projects focusing on African biodiversity and natural heritage have been designed and launched over the past decade. So one important example is the Flora of Kenya, the project which we started in 2015 with the National Museums of Kenya. So following the approach of the joint compilation and joint publication, my colleagues from the Chinese Academy of Sciences have worked closely with our partners at the National Museums of Kenya and some other institutions, including University of Jomo Kenyatta University of Agricultural Technology, Kenyatta University, Masai Mara University, and also KWS, KFS. The project aims to produce a total of 31 volumes, which will documenting approximately 7,000 plant species found in Kenya. So 2 volumes have already been published. We will continue to support field surveys, biodiversity monitoring technology, and conservation projects, including those on-site and ex-situ conservation of plant species, rare and endangered. And also, as we discussed before this opening ceremony, so we will strengthen the collaboration of the training courses for the young scientists, and also we will start the exchange programs of expertise between the 2 institutions. So we will also work closely with African partners to translate scientific achievements into practical benefits for ecosystems, communities, and sustainable development. So today's conference marks a new starting point. Let us work together to protect biodiversity, preserve cultural heritage, and build a more sustainable future for all, Finally, I wish in the second Joint National Scientific Conference every success. Thank you. Asante sana.
Thank you. Thank you, Professor Wang. We come to the end of the opening session, but before we move to other activities, I'm guided that there are gifts for our guests. Innocent, yes. Professor Mary Gikungu presents to Professor Wang and our board chair.
Professor Wang, we have a gift of appreciation for you for support that we cannot explain. We can only say, may God bless you for working with us a long journey of support since 2015, and you are not tired, and for the support to this particular conference and mentorship. Here we have a small gift for you, just to say thank you. Thank you so much. Thank you, thank you, thank you, thank you, thank you, thank you. I'm going to invite the chairman also to come. Chairman, thank you so much for your support. It is highly appreciated. Each time we call on you for support, you are ever there. We really appreciate you, and also for coming to open this conference. We don't take it for granted. Just a small gift to tell you thank you. Thank you, Chairman. Thank you.
No, you have to see.
Thank you very much. We'd also like to request our guests to take a group photo with the participants before we move to other sessions. We'll be guided by Eddie. So, group photo, yes, with all participants. Thank you. All participants, group photo at the back outside, please.
session in the remaining of the day. Since we do not have many hours left, so I hope each presenter take care of your time. Every presenters have the time for 15 minutes. And then at the end of the session, we have a Q&A. And so we have our first presenter. His name is Dr. Christopher Chasira from National Museum of Kenya, brings the topic Regeneration Dynamics in Forest Gap, Environmentals of Kenya's Afro-Montane Forest, Thematic Area.
Thank you very much. So here we are. Thank you very much, and I welcome you all to this presentation. My name is Christopher Chasira. You know, what inspired this research was the need to study regeneration patterns in our Afro-Montane forests, especially in the midst of a lot of for deforestation and pressure faced by these forests, and whether we can still get sustained populations of these of the major trees in the forests. So when I came up with this idea, we approached it in the view of forest taxation. We all know forest taxation is where it's a complex process of how the let's say the dynamism of forest rebirth, and we are now looking at the gaps on now the role of forest gaps in maintaining populations of major species in the forests. So these sporadic events, it starts when a massive tree falls in the forest, and when it falls, it creates a gap, and we consider these gaps as keystone features of the forest, because it enables those plants that are adapted to the light to regenerate. So the process starts with a gap, and very soon pioneer species occupy the gaps, and when the pioneer species are fully grown, they have a canopy of their own. Then the climax species, which are more adapted to the less light conditions, now germinate under the canopy of the pioneer species. And this process goes on until when now the pioneer species are mature. And the same process repeats when there's a fallen tree. So the Afro-Montanes, as you know, are the moist forests of Kenya in Kakamega, Mau, Mount Kenya, and Cherangany, and the rest. We have a lot of these forests in the mountains, and they are moist, and they look like this usually. They are multi-layered. Some reach up to 30 meters, but there are occasionally emergent trees which even reach 50 or 60. But there are several layers of forest canopies, which are also microhabitats or habitats for other species. And even as you go to the undergrowth, you see this is now the floor of the forest, and we have the cyathea, the fern, which also occupies the ground of the forest. So this research was done on East Mau Forest, Lembus Forest, Kaptagat, North Nandi Forest, and South Nandi. And they are here in the map, as you can see, as illustrated. I wouldn't go through them because of time. So the idea was to look on regeneration to see whether there is variation in species composition in GAPs and in non-GAP environments, because we wanted to generally understand the succession process to test the theories of successional groups of plants. And here I mean Pioneer and Climax. So in this research, we went to each of the five forests, and in each forest we had 4 transects, and in each transect we had 4 plots. They were circular plots with a radius of 11.5 meters, which makes it 415 meters square. 80 of them were sampled in all the 5 forests. And to test our the hypothesis on the role of GAPs, we also sought forest gap at least 50 meters away from every plot which we were doing. And inside the gap, we made also nested plots. The first plot is 5.6 meters to make it 100 meters square, because we wanted to sample GAPs which are 100 meters square and above. So we eventually had 52 of them, and then inside the nested plot also we had 5 plots measuring 1 meter square, and we used all this to enumerate seedlings. In total we had 260, and we also wanted to assign successional stages. So we used some literature, because as you may understand, assigning the successional groups is something complicated. Sometimes it needs some monitoring too, because for physiological properties, indicators in the plants, and sometimes also we use more obvious ways like size of seeds, and so those are morphological. So we use this reference from Althoff. He was doing a PhD in research in Kakamega Forest, and we found that the forest we have sampled have so much similarity with Kakamega Forest. So we measured also crown using densiometer, and this is how we made our plots. No need to go through all of just briefly. It's the layout, and of course that's me doing it. And now look at the gaps. We were looking at the gaps and measuring the sizes of the gaps. Remember, we were looking for gaps at least 100 meters square and above. And the plots, the gaps were sometimes coming in different shapes, circular and so on. Quickly to the results, we recorded 132 woody species, those that could grow into trees, from 55 families, 107 genera. Among these plants, we also decided to include some of the climbers, because they have a role in formation of the canopy. We had 8 of the lianas, and they are listed out there. We thought they were playing quite good role in closing up the canopy, and that's why we included. Out of these 132, the tree species were 105, the saplings were 101, and the number of seedlings were 74 species. So using also the reference I told you about from Althoff, we were able to categorize the plants into Pioneer and Climax. We had 22 Pioneer and 66 Climax species. Some of the others were not categorized. So this is the thesis from from Johanna Alto, who did the work in Kakamega Forest. And in the section of his thesis, there is this the checklist here, and as you can see, there is the successional stage, and he also did a lot of classification also, whether they are early pioneers or early climax, and so on. So this, we found this as a very important reference, and I have listed there some of the things we look at when we are deciding whether they are pioneer or climax. So, so these are the number of species. This is a species accumulation curve, and as you can see, it's accumulating well. There's no way you will find a really flat curve when you are doing accumulation curve. So this is pretty good. And now these are the gaps, the forest gaps we were measuring. So from 100 to 1,000 meters square. And we found that a majority of the gaps were around 400 meters square, and those that are below 400 meters square are accounted for at least 79% of all, 52% of the recorded individuals. So in the different forests, these are how the gaps were distributed in the forest. We had more gaps in these 6. Yeah, so they were, well, almost the same kind of distribution in the different forests, the forest gaps. So remember, we were also looking at the gap environments and non-gap environments, and we had more so we had more species, we had more regenerants. This is the seedlings and the saplings in the closed environment, and fewer in the gaps, and we will get to that very soon. So we tested to see whether there was any difference between the two groups when we using the NMDS. And yes, of course, we do not have the stress percentage there, but what came out was there were distinct different groups in the gaps and non-gaps. So there was significant differences in the two. So let's go now to this. I think this is the major results we want to look at. This is what we found: the trait proportions in the different forests. Look at the colors very carefully. We can leave this out, the uncategorized, because we were not able to categorize them into climax or pioneer species. So when you look at this, you realize something here, that our hypothesis is becoming true, that for the climax species, we had more of the climax species in the dark forest, in the non-cap environments. That's where it's the closed canopy forests. And when you also go to the pioneer species, you realize we had more proportions of regenerants, which means the seedlings and the saplings, in the gaps. So it's true then that the first colonizers of the gaps are pioneer species based on this, and that it's true the climax trees are more in the closed forests. So this is actually the main result we want to see. That's what we found out, that it's true, the regeneration theory. And we also to understand the regeneration potential, because we want to know if because we are having increased population of users in the forests, a lot of encroachment to access resources here and there. So we want to see whether if these forests are exposed to this stress, will they regenerate for future existence. So we looked at what we call the IVI. Yes, IVI is important value index, where it's a value we get by combining the relative density, relative frequency, and relative dominance of trees. And the higher the IVI level, it means these are the most important plants in the formation of the forest structure. So we took these plants, these are the seedlings, and they are pretty comparable. They are from the same species, and we looked at their regeneration potential by plotting the number of seedlings versus the number of saplings, and then versus the number of mature plants. And true to all of, they are forming the inverse J shape, which means at least there is a positive transition between seedlings, saplings, and the trees. And yeah, the proportions may be a bit small, but it shows there is a positive regeneration pattern. So, but will it survive the utility stress? So we measured the indicators of disturbances, and we found throughout that there were a lot of encroachment, utilization of the forests, and so yes, there is need to watch for these disturbances. We control them so that we can have this forest in the future. So, because of time, let me conclude by appreciating the Secretariat and these other Kenya Forest Service, my former university, Bruford Foundation. Thank you very much.
Thank you, Dr. Christopher. And so next, we shift our attention from the plants in Kenya to southwest China, another biodiversity report. And Dr. Chen Lishen, his topic is plant diversity in Yunnan. Yunnan is in southwest China, one of the hotspots.
Okay, thank you. Greetings, everyone. Good afternoon. My name is Qian Lishen. I came from Kunming Botanical Garden, which belongs to the Kunming Institute of Chinese Academy of Science. Today, I'm going to share something with you, something about plant diversity in Yunnan and some conservational efforts we do in Kunming Botanical Garden. My presentation mainly covers these 4 parts. First, the plant diversity. Yunnan is located in the southwest of China. And we know there are many hotspots, biodiversity hotspots on Earth. So Yunnan covers 2 parts of the biodiversity hotspot. One is Indo-Burma hotspot, and another is Southwest China Henduan Mountain biodiversity hotspot. And Yunnan has a great elevation difference. The highest point is at the northwest, over than 6,000 meters. And we have very complex geographical conditions and different combination of precipitation and temperature. We all know that the different combination of precipitation and temperature could make up a very complex environment. In Yunnan, we also almost cover all the ecosystem on Earth, except the marine ecosystem and the pure desert ecosystem. Besides 2 of these, we have all the ecosystem kind of the world. And after we studied, we found that there are over or nearly 20,000 higher plants, including moss and liverworts in Yunnan, belongs to 3,000 genera and 440 families. You can see The species number is almost concentrated on the northwest and south and southeast. Besides of this, PSESP, I'll explain this later. The other part of the biodiversity, like endemic species, specimen we collected, and new species we found in these recent years, and threatened species, they're almost concentrated in the same pattern, the northwest, south, and the southeast. And for the analysis of protected areas or nature reserves, we found that the number of the nature reserves is almost concentrated in the east part. But this nature reserves area is so small because the east part is full of human disturbance. And there are many conservation gaps in the east. This means in these areas some threatened or valuable plants distributed there, but not in the reserved or protected areas. In the floristic research, we also know that Yunnan has nearly 20,000, but the central Yunnan Plateau, connected with Yungui Plateau, harbors nearly 6,000 higher plants. And with highly endemism, we have endemic species of 3,000, and we have 800 species endemic to Yunnan. And here are some new findings based on our field investigations. We found some species. We rediscovered these species over hundreds of years. These species only have type specimen, like holotype specimen. But we found it in the northwest of Yunnan in 2019. I think it's more, to some degree, it's more important than published new species because there are some agreements among the taxonomists. They often said, before you put something on the table, you should clean the table first. We can't imagine this situation. If you are going to do a revision in some taxa, but one species only have one broken holotype specimen without any fresh samples, so we can't proceed our research under these circumstances. So we should do more field investigations and found these species back. And Yunnan is also covered two floristic areas, the rhododendron flora and the metasequoia flora, also known as the East Himalaya flora and Sino-Japan flora. And since Yunnan is so important as the plant diversity or even the other taxon diversity, so we should build ex situ conservation and institute. Our botanical garden, Kunming Botanical Garden, was built along with Kunming Institute of Botany in 1968. And this is our institute's model. I personally translated it as to explore the origins of mountains and to classify and name all the plants on Earth. I think it's full of the botanical romantics. And now Kunming Botanical Garden has two parts. One is in Kunming City, mainly harbors the native plants in central Yunnan Plateau, and another part is Lijiang part. This part is hold more species than us because they own Yulong Snow Mountain. The mountain is their backyard, we can say that. And for the Kunming part, we already preserved more than 9,000 species, so 9,000 wild species. And we have 16 specialized gardens. We mainly covered the local species under the near circumstances of climate change. And the Lijiang part already harbors more than 2,000 species. And the elevation of this garden is very high. The least elevation is 2,080. The highest is over 5,000. These are some living rhododendron collection in Kunming part and Lijiang part. This genus belongs to the Alicata family. It's a very big genus. is there are more than 5 or 6,000 species in this genera. And these are some very characteristic for the Yunnan's flora, like this one, the lavai, very common in central of Yunnan. And this Musela is an endemic genera in China, or in Yunnan. And this literally means Gentiana of Kunming. This is a local, sterile, and endemic species. So for Kunming Botanical Garden, what have we done to protect these species? There are 15 Chinese endemic genera distributed in Yunnan, and we already collected half of them, 25. This is 23 or 25, and another half to go. And there are most of the endemic genera we already collected. And for ex situ conservation, like I mentioned before, we have 9,000 species collected in our botanical garden, and we almost preserved over 10,000 species. We know that in China we have 36,000, so we have 1/3 species in China. These are some important and threatened species, like this one, Pinus squamata. It's only distributed on one single slope of the mountain, and Clagia yunnensis and Colibas. And we also harbored too many protected species, especially this one. We have 86 numbers of plant species with extremely small populations. So what is this? This means these plants has very small wild population on Earth in the wild. There is one species named Colilus putoensis. This species only have one individual in the wild. So based on too much human disturbance, these species, like we have several or only one individual species, it can't hold the genetic diversity. So we have to do something about it. We introduce them into the botanical garden, and we multiply them, and we reintroduce them in the wild. And now we have protected 86 plant species with extremely small population, and we already reintroduced more than 20 species into the wild. So what we should do in the future? We want to build Kunming Botanical Garden as Kunming National Botanical Gardens. We already listed in the 40 candidate national botanical gardens. For the layout of our garden, we have Botanical Garden, Germplasm Bank, Research Center, and this is the Lijiang part. And our goal is based on the most concentrated on Yunnan Guizhou Plateau and the south part of Henduan Mountains. And we want to preserve some endangered, endemic, and important economic plants. For now, our goal is preserve more than 11,000 wild species, and most of them are threatened species through different elevational belts. And we also have a PSESP laboratory. We want to preserve more and reintroduce more rare PSESP plants. And we also training the new scientists, new generation of scientists. Okay, thank you.
Thank you for your nice talk. And now we have the third speaker. Her name is Susan Kabasi. Okay, good. The topic is diversity assessment of the microfungi in Mountain Kenya, Nyeri County.
So good evening. Yeah, so I'll be presenting on the assessment on macrofungi that we carried out in Mount Kenya. And this is in support of Rhino Arc with the World Calgary Zoo Institute. And I worked with one of the trackers known as Raphael Gidhui in this project. And so I'll be presenting on a kingdom that has actually not been presented on. I think we have majorly had on plants and animals, but now we are moving on to kingdom fungi, which is the second largest after insects, with the estimates of 2.2 to 3.8 million. But the species that, the number of species that have been described so far is close to 150,000. And this has been the challenge of undersampling, especially in Africa. So most of the tropical ecosystems have not been sampled. And actually this is because of the paucity in the taxonomy and very few people who are not working in fungi. And the major groups are in the division Basidiomycota and Ascomycota. And in this division, most of the work has, actually this is where interest has revolved on, and about 40,000 of macrofungi have been described, yet it is actually suspected that we have a lot in the tropical ecosystems. And why would we want to assess macrofungi? We would want to assess macrofungi because this is an area that has been underlooked. If you look at the studies that have been carried out on animals and plants, then you realize that very little has been carried out to document macrofungi. And as you know, our mandate as the National Museums of Kenya is actually to document. And so this is part of the mandate that we are carrying out. And so you also realize that macrofungi are a source of food, not just to us, but even to the wildlife. And we have conservation bodies that are very keen on conserving macrofungi, but we have to start by knowing where are the species. And so the objective of this study was to actually carry out assessment and to document macrofungi that came out of curiosity. And this curiosity came from this young man in one of the photos. In that photo, Raphael, when he was, I would want to say that we carried out this assessment in Chehe and Ragati forests. So they are doing the reintroduction of bongo, which is critically endangered, and he's one of the trackers. And so every time he went to the forest, he could see these mushrooms that are sprouting, and he really got curious to understand. And that is how we came in to be able to actually even train those who are interested, him included. And so we carried out this survey in various vegetation types. As you can see, the indigenous forest, the plantation forest, different types, the bamboo. In some places, the forest was mixed. And so on the map, you can see how we established the plots, which were 20 meter by 20 meter, and they were 200 meters apart. So these are some of the forests where we did our sampling. And so we collected and we carried out information that relates to the macrofungi of Ragati and Shehe. So what we normally do, including specimen sampling, that is what we were doing in the evening, and entering our data. And so lab work also, carried out lab work to be able to identify this species. And so I quickly go to the results. We found out that we had 160 species which belong to the division Basidiomycota, the Ascomycota, which were distributed in 36 families and in 36 genera. And we had this family Agaricacea, which had most species. And of course, this is attributed to its adaptation and also because of the suitability of the habitat for its growth. Then we had the Bolbitaceae family. This one is, these are mushrooms that grow in association with dung. This could be elephant dung, cow dung. And we had a high number of those species. Then we looked at the substrate utilization. How are these macrofungi utilizing the substrate? Because even as we introducing this bongo, we also need to know, is the habitat threatened? And why in the first place did they disappear? Because they've been tracking for years to really see whether they can have a trace of it. And so we found out that 50% of the macrofungi were associating with wood, and 44 they grew in soil, 5% associated with dung, and there was those ones that are on the ground associating with leaves, and that is in form of litter. And so you can see from the photo that this macrofungi were utilizing different substrates. We had one that was growing on a beetle, and that is one of the species that associates with insects, is entomopathogenic. And you can see the ones that are growing in dung, the ones that are establishing themselves in soils. You can see the wood, the one that is growing, the beautiful one that is growing on wood. And when you looked at the species diversity and distribution in these two forests, what I failed to mention is that we carried out this survey in 2 seasons, in December 2024 and December 2025. And so we found out that in terms of species diversity and distribution, Ragati Forest had the highest species richness of 112 species abundance, and the species diversity was 3.1 compared to Shehe Forest, which had 54 species during the first season, and abundance of 883, and the species diversity of 2.6. And this actually was linked to the strong relationship with the composition, the tree composition that were in the true forests. And also because we were not able, actually, in 2024, we were not able to access the bamboo because of the distance, and also because of the weather. The weather was not very suitable for our sampling. But again, this also shows us that these two forests have very high species diversity. And so when we looked at the macrofungi across different habitats and vegetation types, then we realized that the indigenous forest was very suitable and had very, they had a very high macrofungi abundance. You can see outliers, and from the photo you can see that for some species we were really counting very, very high number of the abundance. The abundance was high because one species was occurring in very high numbers. Then we recorded edible mushrooms. The edible mushrooms are the wood ears. The wood ears are eaten in Western Kenya, in Kakamega. They are also, actually in Western Kenya, wood ear is under regulation so that to avoid overharvesting of this species. It is the top designated as A. And we had also one of the very common mushroom, that is number 3 on top. And it's the most commonly eaten wild edible mushroom. There are some that are actually edible but not common in Kenya. But from literature, yes, some of them are edible. And the orange one is commonly known as witch's butter. I don't know why it was given that name, but it's an edible, slimy macrofungi. So when we looked at the species richness curve, the accumulation curve, you can see how our curve is, and Cecilia can confirm that the curve will never flatten, but you can see that in our initial plots, we were able to record a high number of species, and the curve was actually a bit steep until now. We started we stopped recording the common and the abundant species, and at some point we started documenting the species, the rare species, which are cryptic and could as well be new. In conclusion, I can say that Ragati and Shehe boast a high diversity of macrofungi, and this study is the first in the 2 study sites, and most of these species are first records in Kenya. Recommendation is that because we sampled during 2024 and 2025 in December, could we also probably sample during the long rainy season that falls between March and June, and see whether there's going to be species changes in species. And the other thing is that because, as I've said, that Africa or our tropical ecosystems have been undersampled, could this extend to other forests? And I was making this request to them that if they could, we could also sample from other forests where they are carrying out these very noble activities. Solomon is here. Solomon, you can raise up your hand. He's from Rhino Arc. They came with products. They are selling Eburu honey. So they work in other forests, and yeah, we could still sample in those forests so that we can have more data to add to what we have from this forest. And the other thing, the other recommendation is wood is a good support of macrofungi, and there should be regulations to control its harvesting, because we found over 50% of the macrofungi associate with wood. And with that, I want to say thank you. These are the community, these are the people that I worked with from the community in Ragati. And these are the young men that are involved in tracking Bongo, and our securities from PWS and KFS. Thank you.
One looks edible mushrooms. Some of them, so it will be cautious. Good. Now we have our last speaker, Beryl Bong from National Museum of Kenya. The topic is ecological assessment of Shimba Hill reed frog in Kwale County, Kenya, and its distribution, population size, and breeding patterns.
Good evening, everybody. On behalf of my colleagues, Patrick Malonza and Josh Nyamache, I'm going to present to you ecological assessment of Hyperoleus rubobamicillatus. This is a very beautiful frog. And if I say beautiful, I'm not just talking. You can see from the photo that this is a very beautiful frog. So this frog is not only beautiful, it is also unique, because for you to see this frog, you have, in its natural habitat, you have to travel to Kenya, and not just any other place in Kenya. You have to go specifically to the Shimba Hills. So this frog is threatened, and if you go to the IUCN Red List, it says that the quality and the quantity of the habitat of the Shimba Hills reed frog is decreasing, and it also says that what are some of the conservation actions that are needed to save this frog is one of them is ongoing and improved habitat protection and management, and then we also need research on distribution of the species, its population size, and taxonomy. So our research tended to tackle components of these two actions that are needed to save this frog. Unfortunately, little else is known about this frog, and this is not unique to this frog. Most of the frogs we have, we just know that it's found in this locality. We don't have data on the abundance, and we also don't have data on the natural history. So that's why we embarked on this survey. So the objective was to investigate the natural history of the Shimba Hills reed frog to provide information that can be used for its conservation. Specifically, we wanted to establish its distribution within the Shimba Hills National Reserve and to investigate the breeding patterns, because when you want to conserve this, a species, you really have to know how certain aspects of its natural history. And we also wanted to estimate its population, because again, if you look at the IUCN Red List website, it talks about reproductive units of this species is not known. So we thought maybe if we give like a baseline of the population in Shimba Hills, it could be a start towards its conservation. So we also wanted to document threats and conservation needed. So as I've said, the frog is found in Kwale County, and one of its habitat or localities is the Shimba Hills National Reserve, located 30 kilometers away from Mombasa. The Shimba Hills is famed for its biodiversity. The botanists in the room will agree with me that it has one of the, maybe the highest, if I'm not wrong, plant diversity, or rather unique, or in terms of endemism, and also birds and mammals. And as far as amphibians are concerned, it is one of the highest ecosystem in Kenya. I mean, it has the highest diversity of amphibians in Kenya. That is over 30 species of amphibians. And so that is the map of Shimba Hills, and 1 to 15 are some of the localities that we sampled in. So we did 3 main visits to the Shimba Hills, accumulating into 23 days. The first was in June 2023. We went back again in November 2023, and lastly in June 2024. And the main method we used to look for this frog was what is called time-limited survey, where we visited a wetland, and then we searched for the frog for 1 person hour. That is, if we are 2 people, we search for 30 minutes, and then we document what we found after 30 minutes. If we have 3, then we search for 20 minutes. So we started our sampling during the daytime around 9:30 to 12 noon. And then this is mainly to identify the wetlands and to see how we can navigate. And then you would go back again in the evening from 6:30. And then every habitat we went, we counted any specimen of the species that we found, if we were able to detect the sex, and also the perch height, that is how high was it perched on the vegetation of where it was found. And also if they were calling, we were used a digital voice recorder to record the frog, that is the male frogs, and also the position it was while it was calling, we were noting. So we recorded about 640 individuals, that is comprising of 385 males and 255 females. In our sampling, we recorded 219 samples. And in the second one, we collected 180, and the last we got to 41. And then the highest number we found in a swamp. Mwadambara is a swamp within the National Reserve. And then the list where we got only 9 specimens is a swamp, a small wetland just adjacent to the reserve. So out of the 15 sites we sampled, we recorded it in 9 sites. And then 2 of the sites were new. We called them new because previously we did not know that it occurs there. 2 of these were within the Shimba Hills National Reserve, and 1 was outside. So, and then one thing which we also noticed that the color of this frog was very, it had very diverse color pattern, because for you to identify the frog that you know, yes, I'm dealing with Shimba Hills reed frog, you have to know how it looks like. But the frog has a diverse color pattern. Like this one is the color that is mostly known. If you Google Shimba Hills reed frog, this is what is normally you see. But then during the daytime, we're getting this color, and sometimes we're also getting this color. So all these are just the different color variations of one single frog. And it was interesting that in one site you could get all of them, but then if the males had rough skin compared to the females. So I would just mention that about the typical brown dorsum that is known for the frog. But then we also got the ones of this color that I've already mentioned. So we recorded a male bias sex ratio in most sites, and that is like the norm, because the males come early to the breeding site so that they call to attract the female. But it was interesting that during our second survey, we tend to get more females in the sites than in the males. So, and then we noticed that the males were calling, they were motionless, and they tended to call on vegetation which was either inside the water or beside the water, but they were not calling within the water. And the call site was roughly from 1 to about 2 meters above the water. And then they used to call between 6:30 in the evening to way past 7 or 8 p.m. And then we also noticed that in the more open areas, they called late. I think it's because in the forest, it tends to get dark early. So at 18:30, that is the habitats that were deep within the national reserve. And then in more open swampy areas, they started to call a little bit later. And then most of them remain hidden. That is the males that were calling. Sometimes you hear the call, but you don't see the frog. But because we know the call with experience, so we could just say that, oh, we count it as one of the frogs. And then we also able to record, during all this time, we only recorded 3 amplexing pairs. Amplexing is that when the male and the female in the mating position. And that one was in November 2023. And we also documented the eggs. We counted 61, and the highest number was found in Risley Ridge, which is also another forest fragment deep within the forest. And so these the frogs of this frog, the eggs of this frog, they lay them on leaves, and then in white colorless jelly, and as the embryos develop, they move from the original position of laying until they come to the tip of the leaf, and then when they are mature, the tadpoles drop in the water and the development continue inside the water. The eggs, we counted an average of 100 and individual eggs, the white things you see here, eggs, counted an average of 119, and that was the range. and they were deposited within the forest. They tended to use broad-leaved trees, and in the swamp they used ferns or other aquatic plants. So they are mainly in the primary and secondary forests along the riverine and hidden vegetations, but we never saw them in cropland, especially when we were at the sites outside the reserve. And that most of them, we found them above the water at that level, 0.5 meters. And they preferred shaded areas during the daytime. I have a photo, I'm not sure if you're able to see it. So this is a aquatic plant, and this frog was trying to hide from the sun, and you can see there's just the small section of the grass where it was hiding. And these are some of the plants that we noticed that the frog used. So the botanist in the room, you can help me identify some of these. But I was told that I was interested in this one because I found it really preferred this one. If you remember the slide before, it even laid eggs on this one. Then I was told that it's an invasive species. So I was just wondering how come it came to like it. And we also noticed we never recorded any threat in terms of habitat destruction within the reserve. But we noticed that we also never found any predator feeding on the adult frog. But we noticed that we had several invertebrates that were feeding on the eggs as they were developing. And also we recorded 2 snakes. These are potential predators because we never saw them feeding on this frog, but we know that snakes, especially when you find them in breeding site, what they do is they feed on the frog. So these are potential predators for the frog. So our study was not necessarily new because a little bit of information was available on this frog, but we provided more information about what was new, but a few others were new. Like now we know that we have 7 breeding sites of this frog within the reserve and 2 outside, but the full extent of this species is yet to be established. And occurrence of this species has also been recorded previously. In 2 forest reserves, we have the Buda Forest and Gongoni Forest, where the species has been recorded before. But all we can say that a high percentage of the species preferred microhabitat occur outside the protected area. So that calls for us to really work with the local communities because this is where the frog is mostly found. So again, in terms of color, initially we thought the females were more colorful, and that is true for most amphibians and reptiles. No, that is not true. Most reptiles and amphibians, the females tend to have dull colors, the male are more colorful. But this frog, the female were thought to be more colorful, but again, during our survey, we found some males which had the same color, which initially we thought were females. And then color variation in this and the frog family Hyperolid has been documented before, but what really stood out in this species is that within a small area you find like 5 different color variation, yet its sister species, which is called Mitchell's reed frog, which occurs from northern Tanzania all the way to Malawi, has just 1 color pattern. So it's something interesting, and I think maybe we might need to do some research to find out what really is going on with this frog in the Shimba Hills. So again, the call of this frog had already been described by Alan Channing, but we add information on the call sites and position of the eggs, because this is important when you want to conserve this frog. Maybe the vegetation you want to cut, this is where the frog lays its eggs, or where the eggs are deposited. So when you bring this information, we hope it will help in the conservation of the frog. And also we bring data on the clutch size of these frogs, which compares to a corn specific from Western Africa. And the frog is also exclusively associated with forests and forest clearings, but we have no records of it in farmlands. And again, I just emphasize on the importance of preserving indigenous vegetation for the long-term conservation of this frog. So, as I mentioned, we did not get any predation on adults, but from literature, it appears to affect all stages, because ours we only reported on eggs. But Malonza et al. Observed the juvenile of this frog being fed on by a spider of Nilus sp, and also the 2 snake species that we recorded are known to predate on frogs. Even if it doesn't, we never found them feeding on these, the potential are they could be predators. So our data provide our research provide baseline data on the abundance of this frog, habitat use, and build on already known information on breeding and distribution. And we recommend future research on understanding the color pattern variation and distribution outside protected areas if we are supposed to fully conserve it. And then we create awareness among the communities. And I'm happy to say that during our work, we interacted with communities a lot, and we told them about the frog. So thank you very much. I would like to acknowledge my team, and the Mohammed bin Zayed Species Conservation Fund gave me the money to do this work. Research permit from WRTI and NMK. Thank you very much.
Thank you very much. Thank you for your nice talk on frogs. Now we shift to the following speaker. His name is Dr. Yi Huatong from South China Botanic Garden, Chinese Academy of Sciences. You know, here we have, it seems like Kenyan people love bamboos, and we found that they cultivate in many places. And as I know, only one indigenous, or we say native bamboo species in Kenya. Back to China, we have quite a huge number of species. So the topic is about the taxonomic distribution for a typical genus Sasa species from China.
Good afternoon, everybody. Today I'm glad to be here to share some our work on the taxonomic revision of a genus called Sasa. First, let me give you some introduction about bamboos. The bamboos belongs to the grass family, Poaceae, and subfamily Bambusioidea. It contains about 139 genera, and more than 1,700 species in the world. In China, there are about 39 genera and more than 500 species. As we know, the bamboos are very useful from construction, food, ornamentation, medicine, and cultural. Although bamboos are useful, but bamboos are also a taxonomically difficult group because they have a very long flowering cycle from 20 years to more than 100 years. And also it's not easy to prepare the bamboo specimens because you need to collect the rhizomes, the culm leaves, branch leaves, and some other parts. So now bamboos were classified into 3 tribes. The biggest tribe is Bambusiinae, also called tropical woody bamboos. The second is Arundinaria, also called temperate woody bamboos. The third one is the herbaceous bamboos, called Oliva. It's mentioned that there are more than 400 species of Arundinaria in China. So China is a biodiversity of the Arundinaria. Today we'll share a genus belongs to this tribe. And this genus is called Sasa. Sasa is a Japanese name. It means a small bamboo. So Sasa contains about 50 to 70 species, mainly distributed in East Asia, like Japan, Korea, Russia, and China. There are about 16 species in China, only distributed in the south of the Yangtze River. and all the 16 species are endemic to China. Next, I will introduce some diagnostic character about this genus Sasa. So Sasa is a shrubby bamboo, have leptomorph rhizome, which means the culm is diffuse, not close to each other. And each culm node with one branch. This is very unique because only one branch at the node. And then the spikelets were arranged into a panicle. And each spikelet with 4 to 10 or more florets. And each floret with 6 stamens and 3 stigmas. So these are the diagnostic of this genus. And these are the 16 species from China. The first one, only 2 species has flowers. Only Sasa sinica and Sasa bonolis. All the other species were described without flowering material. So we sampled most of the 16 species and find that the Chinese Sasa species is extremely polyphyletic. You can see the red species are from China. They are distributed in the many clades of the tribe Arundinaria. So traditionally, the Sasa was divided into 2 subgenera, subgenera Sasa and subgenera Sasamorpha for Chinese scholars. But for Japanese and other countries' scholars, they adopted the Sasa sensu stricto and also some small genera like Sasamorpha, Neo-Sasamorpha and Sasaella. So first, let's look into the species of Sasa subgenus Sasamorpha. The red box were species of Sasa subgenus Sasamorpha. It's far related to the blue box, the type of the genus Sasa vicia. So, and morphologically, we can see the species of Sasamorpha have different shape of culm bud, and the node is flat. It's very different from the ovate bud of Sasa, and strongly raised culm. And their flowering morphology also different. So we draw the first conclusion is that Sasamorpha should be separated from Sasa. As for the subgenera Sasa, the Chinese subgenera Sasa is also further related to Japanese Sasa, which means the species of Chinese subgenera of Sasa also very different from Chinese Sasa. As for the morphology, we can see this is the earliest species of Sasa, subgenera Sasa from China. It's called Sasa longiligulata, which was described in 1940 from Luofu Mountain in Guangdong province. When it was described, there's no flowering material. Until 2008, E et al. Described some characters of the flowers. They found that this species owns 2 stigmas, but the stamen number was unknown. Until 9 years later, we luckily collected its flowering material again, and we are certain that this species has 3 stamens and 2 stigmas. Now we can have a thorough comparison of Chinese Sasa species and the Japanese Sasa species. We can see that the spikelets were arranged into a raceme, not panicle, and one spikelet only has 2 to 3 florets, not so many as in Sasa. And each floret has 3 stamens and 2 stigmas, also very different from the Japanese 6 stamens and 3 stigma. So, we draw the second conclusion is that both molecular and morphological evidence support the establishment of a new genus, Cynosasa. We also conduct a thorough revision of this new genus and find that there are about 9 species of this genus in China. Now we know that 3 species should be in Sasamorpha and 4 species should belong to Cynosasa. For the rest 9 species, we have located all the type specimens and found that even from the specimen we can know that some species bear 2 or 3 branches at each node. It's different from Sasa. And some species only contains a young culm without any branch information or rhizome information. So we need to go to the type localities and collect the complete specimens to identify which genus they should belong to. These are they are from the 9 species from Hong Kong, Hainan, Guangxi, and Guangdong. And the first one, we confirm that the Sasa guangdongensis is a synonym of Acidosasa carinata. The 2 species are distributed at the same mountain and shares exactly the same morphology. And for Sasa tomatosa and Sasa lupula vaginata, we can see that they both share long-necked parthimorph rhizome. As we know, the Sasa is leptomorph rhizome, so the rhizome shape is very different to differentiate different genus of bamboos. And the long-necked parthimorph rhizome is a key character of Eusania. So we translate these 2 species into Eusania. And Sasa oblongula was confirmed to be a species of Pseudosasa, rather Sasa. So we have a revise of all the species and found that all the Chinese Sasa belongs to 1, 2, 3, 4, 5, 6. Belongs to 7 species, 7 genera. And as the last one, Sasa arboceriata, we confirm that it's not a Sasa, but a further study is needed. Actually, we think it should belong to another new genus. So this is a series of papers we have published during the whole from 2021 until now. So the final conclusion is no real Sasa species in China. This is an extremely case of technical revision about the genus. At first, we have a thinking that this genus is problematic, but it's astonishing that we don't see. When we have revised all the species, we found that all the 16 species are not Sasa. So from this case, we can learn that only through taxonomic revision can we obtain accurate data on species, which are essential for other disciplines that rely on this data, such as systematics, biodiversity, phytogeography, and so on. So I appreciated all the members of our group and the financial support from some agencies and the field herbarium work. Thanks for your attention. That's all.
Thank you. Thank you for your nice talk. And now we have our presenters from Rwanda. His name is Ernest Umimana from Dien Fosi Gorilla Fund in Rwanda. His topic is assessing forest landscape restoration in force using non-violent small mammal habitat, modeling around the Nyandugu Eco Park in Kigali, Rwanda. Yeah, it's a nice artificial wetland. I've visited that place twice.
Good evening, everyone. My name is Ernest Wiman from the Danfoss Gold Fund. I will be presenting the topic Assessing Forest Landscape Restoration Efforts using Non-Violent Small Mammal Habitat Modeling in Nyandungu Eco Park there in Kigali City. Here are my supervisors, Richard Kalangwa, Methode Majambere, and Dr. Deo Glacias from the Danfoss. Forest landscape restoration has emerged as a vital conservation strategy aimed at reversing forest degradation and restoring the capacity of ecosystem to deliver essential services such as carbon storage, water regulation, and soil conservation. But achieving this goal not only require these restoration interventions, but it can require just to use this variable ecological indicator just in order to measure how the forest is functioning. That's why we have chosen non-violent small mammals. When I say non-violent, it means terrestrial, that ones that are walking to the ground, mainly rodents and sloths, because they are very key, important ecosystems. And some of the studies have reported that rodents are ecosystem engineers through they prey through digging and burrowing down in the soil, where they do what we call soil aeration. And due to the fire they have, they do what we call seed dispersal, which leads to the forest regeneration. Another one, due to the burrow underground, they do what we call decomposition, which leads to the nutrients recycling. Their diversity, they vary with how the forest is either in early succession or in late succession stages. You can see how the urban wetland how was before restoration and now how it is. In this context, just in order to know how if the forest is achieving its ecological intentions, that's why we use the species distribution model, just in order to support that ecological monitoring and in order to predict where these habitats can be functioning well. We will integrate the field data with the remote sensing in order to map that habitat suitability, just in order to understand which key drivers are driving this species distribution. Left side to the figure, you can see we will take some of the environmental variables, either it is vegetation cover, and we incorporate the statistical model just in order to see which area of the habitat is it either low, suitable, high, or moderate. The problem statement, since 2016, Rwanda Environmental Management Authority has developed a project of restoring Nyandungu, but they have never just linked how non-violent small mammal and these vegetation chains can just intend the ecological changes. In 2023, it's when they have been done the baseline study, but nowadays they have not done they have not linked what the vegetation change and habitat suitability. That's why our study is going to solve that problem by integrating those field data with spatial modeling in order to effectively assess forest landscape restoration in this urban ecological landscape. The first objective is to assess habitat suitability for small mammal across different habitats and microhabitats using field trapping and spatial analysis. We predicted that habitat suitability for small mammals will differ across those habitats and microhabitats within the park. The second objective is to identify the key environmental variables that is shaping this small mammal community distribution. Vegetation dynamics, area and difference vegetation index, canopy cover, ground cover, or leaf litters can explain small mammal distribution better than relying on topographic variables. We will evaluate the change, those ones for 2016 pre and where they have done the survey 2023 and now how the current situation is. We predicted that the restoration-driven vegetation complexity, either if it will be high, be having like more food resources, will provide better habitat and more suitable for these mammals. This is the study area. Most of the people I think here, they don't know that place, but Nyantongo Eco Park is located in Kigali City, and it have 5 sectors where the first sector is where there is a matter of all attenuation plants, and it is very, and it has attenuation ponds like Lake Ihema, like Pond Ihema, and the sector 2 is the one which is the small, where some of the frog species are mostly occurring because it is like a pond, it is like an urban wetland, where the first one, just its main function is where the water end starts, and then they do filtration of the water to the sector 5. Sector 3 is the main one where most of the visitors, when they are coming there, they visit. Sector 4, it is like a sublink of the ecotourism of Sector 3, where most of the people who wants to see the birds goes, and Sector 5 is the ending point, just where the water filtration occurs. We chose rodents and sloths as non-violent small mammals because they are very good bioindicators of ecosystem health, and they can, most of the studies have been reported to use in order to measure the forest landscape restoration success. For the sampling design, we will use stratified random sampling. The first trap will be placed randomly, and we place the 10-meter distance across each trap per sector. Then the traps will be baited with peanut butter and white oats. There you can see, and we use the cotton just in order to prevent hypothermia for the small mammals, in order to take their ethical considerations. And we will use a shaman trap, and we will use a cloth bag or a mesh bag while measuring some of the morphometric measurements. And the traps will be checked twice a day, morning and afternoon. And at the center of each trap, environmental variables like the air temperature and air humidity will be taken using thermohygrometer. Soil temperature will be taken using penetrometer. And Soil penetration will be taken using penetrometer, soil temperature using thermometer, soil moisture is moistometer we'll use. Gland cover, we will either classify them in order to know the leaf ones, the wood debris, and the water, just in order to classify the ground cover. Also, the canopy cover will be measured using forest densiometer at the center of each flap. Habitat assessment will be done across each flap where the trap is, in order to identify the major plant species which are there. Data collection, we will code the species, the sex, and the body mass using Pearsall hanging scale, and the morphometric measurements, either the body length, the tail length, the hind foot, using the Lola graded in millimeters, and we will do capture mark capture using a permanent marker, because most of the studies have been reported that ITAG is not well considered as for the small mammals, so that's why we have chosen the permanent marker which sticks on the palm of the hand. We will collect some of the habitat data, either the soil condition or the distance, and also we obtain like a land cover and NDVI from World Climb 2 in order to reduce that cloudiness using the Sentinel-2. We will identify them using the field guide to African mammals. You are seeing the max extent is the model we will be using, because it deals with the present data only, and the small sample size that will be used in order to create these suitability maps, and QGIS for generating maps from the distance to the park load, in order to calculate how much where the trap was, and other software will be used for other statistical analysis. Like the key takeaway message for you everyone, most of the people, you celebrate the success, but every success there is a person who is behind. That's why we chose these small mammals. It will be like a baseline reference for future studies in urban and peri-urban studies, and it will detect and document those changes over the species composition. By producing these maps, it will support decision making in order to know does the forest or the urban wetland, is it functioning well? Just because most of the studies we are dealing with the past, but we don't know what we are doing, is it working? That's why we must evaluate whether the restoration actions are achieving the intended ecological outcomes. Another one, this study is important because it shows the biodiversity value of Nyandungu, especially small mammals, as they are often seen. By understanding these species and their habitats, we can better demonstrate ecological richness of the park, which supports ecotourism development. When visitors and investors see the park has high biodiversity and well managed, it increases interest, attraction, and willingness to invest in ecotourism. My special gratitude goes to Second Joint International Conference Committee who has prepared this conference. Thank you, everyone.
Now we have our following speaker from Kenyatta University, Juliana Anyagi. now shift to the following one. And finally, we have the last presenter. His name is Julius Nguku from National Museum of Kenya. His topic is assessment of the fish species along northern Ewaso Ingis River basin in Laikipia County.
Good evening. My name is Julius Nguku from National Museums of Kenya, Archaeology section. I want to present to you the results of an ongoing project which is trying to look at aquatic species that are being used as bioindicators of a river ecosystem health. In this project, I think 3 taxas were used to assess the health of river ecosystem. And I want to present the results on one of the taxas, that's fish. I won't go much into the introduction because there is no time, but we know that aquatic ecosystems provide intangible systems such as the provision of natural aquatic habitats, sources of water for human, livestock and wildlife, and again for agriculture and fisheries, recreation, tourism and socio-economic services. We also know that aquatic ecosystems as rivers and lakes provide sediment, nutrient retention, processing, hydrological regulation and cultural roles. Fishes as well are important as a source of food, biological indicators of water quality as per the project, and also they play important processes in food web dynamics and as keystone species. There are threats to these species such as drainage of swamps, diversions of water for agriculture and industrial and domestic use. Deforestation is also a threat, industrial and agricultural pollution, river damming and flow modifications. Introduction of alien species is also a threat to some of these species. Climate change as well, because when we have prolonged droughts, you know that temperatures rise due to reduction of water flows. Our main overall objective was to assess the fish species, diversity, abundance and distribution as bioindicators of ecosystem health. Before, during and after the interventions of the upper part of the northern Ewaso Nyiro Basin. And our main objectives were to investigate the diversity, abundance and distribution, to also look at the indicator fish species in this upper part of the basin. We also try to determine some physicochemical parameters such as oxygen, temperature, TDS, conductivity and pH. We also tried to identify some globally threatened species and also document threats to the fish and their associated habitats. We were also looking to providing recommendations for improved conservation of this ecosystem. This is the study area, which is if you look at this part here, this is the upper part of northern Ewaso Nyiro Basin that we tried to look at because we measured on that part. And this covers around 15,000 kilometers square. The northern Ewaso Nyiro Basin has its source, that is Mount Kenya and the Aberdares. So we looked at the source, that is the Mount Kenya source, which is this point. Our sampling sites, we identified around 20 sampling sites that contributed to around these sites were from around 8 from the upper side, and the upper side of the study area had seven sites, the mid had around 5, and the lower part had around 8, which also contributed to mid and lower points. This study was carried out in 4 surveys from 2024 to January 2026. You can look. There's a map there that shows. These sites. We employed several methods for fishing: the seine net, electrofisher. With the electrofisher, actually, we try to shock the fish. We don't kill them; we shock them. We make them not move, actually, so that we can be able to catch them. We also used seine nets and anti-nets. Sometimes in the clear waters, like in the upper parts of the rivers, we did a direct observation because the water is actually very clear, and we were able to count the fish. For water parameters, we used a multi-parameter probe meter to record these parameters. I want to go into the results. In our study, we recorded around 10 species during the 4 surveys. And if you look at the table here, you see that one of the species, which we call it the Bearstone lapper, was the most diverse and the highest habitat. In the first survey, we recorded around 7 species. The second one 5, then the last, the following one 5, and then the last one that we conducted this year yielded around 6 species. 6 species. We looked at the distribution in the actually upper, mid, and lower sides, and we realized that the upper side had only 1 species, that is the rainbow trout. The mid had 5 species, and the lower course had 8 species. Actually, if you look at the lower course, which had 8 species, we expected more than this actually. There were sites that did not record the fish species. The 7 sites of them did not record 7 species because most of these sites did not have enough water, and others were very dry, and others did not have at least anything. Our objective, I think this was objective 2 or 3, we were trying to look at the indicator species, and we came around in the upper part of the system. We identified 1 indicator species, that was a rainbow trout, and if you look at its abundance, you see that its abundance is actually varying. The first survey recorded we counted around 120 specimens in the dry season. In the next dry season also, which was in this year, this year, there were only 79. If you look at the wet seasons in between 2024 and 2025, its abundance was also varying. It increased somehow. The mid causes, we had the stone, the Bearstone lapper, which we also used it as an indicator species in both the mid and the lower. In the mid course, we expected to get another indicator species, which we call it the mountain catfish, which is supposed to be occupying the mid part of that upper ecosystem. This species used to occupy the upper part before the introduction of the troutfish. But when the troutfish was introduced, this fish moved downstream to the mid part of that upper basin. But all the same, we didn't record any of the specimens in this part of the ecosystem. When we move to the lower course of the river, we also used the Beaston lapa as an indicator species, which had higher diversity and abundance than the middle part. We also had Pangani bulb in the lower part, but we didn't record in the first two surveys, but it was recorded in the last two surveys, that is in 2025 and 2026. I don't think whether you can see the down part of this. There is another species here we had expected to get, which is endemic to the upper part of Ewaso, northern Ewaso Nyiro, and we didn't record any of these species. We didn't record any specimen of this species. So, yes. We know that fish are highly responsive to environmental disturbance and pollution levels and habitat degradation. Thus, they play a crucial role as bioindicators in assessing the health of river ecosystems. We tried to measure with the water parameters, we tried to measure with the dissolved oxygen and temperatures. We know that aquatic systems below dissolved oxygen reduces survival of fish. If you look at these two tables, you find that the upper part of the reef of the ecosystem recorded higher levels of oxygen. You look, this is 8. Yeah, as we go down, the amount of oxygen naturally reduced. If you look at the temperature also, temperature was lower in the upper parts of the ecosystem. We also tried to identify the threats, which we came up with a list of threats. Actually, the major threat in this part of, especially the upper part of the upper North Ewaso Nyiro Basin, is water obstruction and diversion. You can see the number of pipes down here. This is in one of the sites, which is Tereswani. These pipes were around 14 of them. And they were actually installed in the source, in the spring where Tereswani starts. Overgrazing, you see that this herd of cattle, this is within actually the forest area, is where one of the river sites starts. There was a lot of actually riparian farming, which actually contributes to erosion, siltation, and temperature increase. Pollution from agrochemicals and car wash. In fact, some of these rivers passes through some urban areas like Timau. This dump site here is actually almost around 5 or 10 meters from Timau, mid-Timau River. Deforestation, we actually know that it's a threat because upstream, even in the forest, deforestation is still going on. Developments along the river banks was also another threat. Prolonged droughts. The first study was actually done after a prolonged drought. Then actually we were sampling after a prolonged drought. Some of the species were actually recovering. There is another threat that we found out, chemical fishing. If you look at this specimen here, this is one of the specimens we collected in one of the upper sides of the river, that had been killed by chemical fishing. When we tried to inquire, we were told that there is some chemical fishing going on upstream. They use herbs. They use herbs to fish. It's easy to use herbs in some of these areas because when you put the herbs into the water, some of the fish die and they float, and then you can easily pick. So this is one of the threats in that ecosystem. If you look again here, agrochemicals, these are some of the photos we took from the chemicals that are using in the farms. Conclusion. And my conclusion to say that species diversity shows an increasing trend from 7 to, in the first survey, they were saying that they continued to increase. But all the same, earlier surveys have yielded more species than we recorded. no globally threatened species were recorded, but two key indicator species that I've talked about were not recorded. The Wasonyiro labeo, which is endemic to the upper, and the mountain catfish, which occurs in the upper Tana and upper Wasonyiro. We had a first record of an introduced species, which we call it the Crucian carp, which was introduced during the colonial era, and we were wondering how it found itself to that place. But because this is a species which is an ornamental one, which is used in aquariums, maybe somehow it found its way into the system from an aquarium. There is a lot of pressure on fish diversity, that's what we found out, and the abundance due to threats on the habitats. We tried to come up with several recommendations. One of the major ones was restoration of the upper courses of the rivers, and I think this is one of the objectives of the major project. Initiating alternative livelihoods. These are, for example, biodiversity-friendly livelihoods, aquaculture, beekeeping, agroforest, such kind of things. We also recommended for promoting the use of organic inputs in agriculture instead of using chemicals. We also recommended river pegging to mark the riparian area so that people do not farm close to the river, because we know the results that come from farming along the river banks. We recommended enforcing and implementing wetland policies by strengthening the RUAs and the CFS. We were told this morning that we have these policies. The only problem is implementing these policies and enforcing them. I think I mentioned about aquaculture, but in this case, we recommended this one in this area as an economic option for better use of water from the rivers rather than irrigating the area, because irrigation uses a lot of water, and most of these aquaculture activities, the water passes through the ponds and it goes back into the ecosystem. We know that there are some other impacts, like species coming from other areas might interfere with the natural species in that ecosystem. But if this one is done well, then it can be an economic option for the area. Again, for economic purposes, we also recommended for introduction with precautions for trout, because we found out that there were streams that were flowing from Mount Kenya that did not have trout fish, so we recommended for such introductions. And I say especially in rivers that do not have other natural species. We also recommended on sampling additional sites so that we may find out whether we can come up with the two missing species, the mountain catfish and the Wasonyiro labeo. That's why we thought of going to the Alpha-Jetta protected area to find out whether these species might have escaped into that protected area, and also in Aberdare, which is also another source of the Wasonyiro. Thank you very much.
Thank you. So now we finish all the presentation in the afternoon, and now it's evening, a little late, so we just have a quick Q&A, and so we're going to have 2 or 3 questions. Any comments, suggestions would be welcome. Anyone? Rest for the dinner, maybe take it back to the hotel, prepare your home, and so if no more questions, we're going to close the section in the afternoon, and we'll see you tomorrow morning. If you all have a lovely evening.